Okay, so now we have a complete data table, and we need to know how to make a graph for this data table using Google Sheets. Pardon me. So a really good idea if we're going to, first of all, I need to mention that you might not see what you need to see. Originally, this arrow over here on the right minimizes the number of options you have. And if you drop it down, you see more options. So you need to, in order to make the chart, we're going to have to use the insert option over here. Let me make sure that you can see the insert option. So you may have to expand the toolbar in order to be able to see it. So you'll notice what I just did. I highlighted the data. It's probably easiest if you only highlight the numbers. All right. And it will automatically use those numbers when I go to put in a chart. Okay, so I'm going to insert and go down to chart. And Excel, unfortunately, I'm sorry, all of these spreadsheets are really business oriented. They're not very scientifically oriented. So most of your options are things like bar graphs and pie charts. Okay, so you have to look under chart type. And the most scientific option we have here is the scatter plot. So let me make a scatter chart. Okay, so that put my data in. Okay, and you can see the stretch data is on the x-axis and the force data is on the y-axis, right? So we have a chart now. Okay, now that we have the chart, we can go through the process of customizing it for our specific data. So as I look at this, everything looks pretty good for the main setup. If you hadn't selected your data, you could do that right in here. See data range. It's from C5. That was the upper left. That was the C5 would be the top force value. I'm sorry, stretch value down to D13. That would be the last force value. So that corresponds to what we boxed in. You could change that by hand if you hadn't boxed it in ahead of time, but it's more convenient if you do. Now we're going to customize the chart. Okay, so we have our data in there. There's not a lot we can do with style. Okay, so there's really nothing that I want to do with the style. So I'm going to go to the chart title and axes. Okay, so while you're looking at the chart title, and once again, remember to pause this video as you do things because you won't remember it all when you get to the end of the video. The first thing you probably want to change is the chart title. So this is for, spring 1 stretching. And this is our force, spell that correctly, force versus time. All right. Then you can go on down. So that looks like what I want there. You can choose all kinds of things with the title. Okay. You can choose the font. Don't do anything crazy or fancy. Keep it black and white. Don't make it curly in writing. Maybe I want to change the font size right now. Let's say for like 12. That's way too small. So maybe I can scroll down and give myself a little more room here. 12 is way too small. Let's say 24. That looks about right. Okay. So you want the title to be nice and large. And so I have that. Actually, maybe I want to use a colon after spring. I'm going to go back and change that to a colon. Okay. Now I can make it bold. That might be nice. All right. And so don't italicize the title. I could center it. That's nicer. All right. You could change the color, but let's do it all in black and white. This is science, not digital design. Okay, so now go to the next thing, series. So we finished with, oh no, I need to go back. I'm sorry, because I've done the title, but I haven't looked at the axes. So there's a drop-down menu here. Okay, so I did the chart title. I could do a subtitle. I could do, now I can do, but I won't worry about that. I'm going to do the horizontal axis title. Okay, and that was stretch. The horizontal was the stretch in meters. Oh, it popped up as an option. I think I typed it in earlier. Okay, so the stretch in meters came up, but I can type that in as for the horizontal axis. And if I look at that, you know, maybe I want to make the font size a little bit bigger. Will it let me change that? Oh, title font size. Auto right now. Let's make it a 16. See what that looks like. Oh, that looks better. Okay, probably a good size there. Now let's make that bold. It's already centered, so I don't really need to do anything with that. So now that looks good for the horizontal axis. Now I should switch over to the vertical axis. That's the force in newtons. Since I had typed this in earlier while trying it, it popped up. I don't need to type in force in newtons. That was just the last thing I had typed in as I was practicing it. You probably want the font size to be the same size. I believe that was 16. And if I make one of them bold, I should make the other bold. So there we have it. Okay, we've just added a title, and we've added axes labels. So continuing, now we're ready for the next thing down. It's good just to go through progressively so you don't miss things. All right. So I could change the color of my data points. That doesn't matter all that much. I can change the shape. I can have all kinds of things. If I had more than one set of data, I might try other shapes, just so that it would distinguish the data. And let's see, do we have axis? I'm not quite sure what, let's go, yeah, let's stick with left axis. I think that lines it up directly on the left. We're not going to format the data point. Okay, now we can't put in error bars because there's nothing, it just automatically put in a 10% error on every data point. That's not helpful in our case. Okay, we don't know what the error bars are. You could actually do errors as a percent or as an amount. All right. So if we were uncertain about how big the forces were, we could do that, but we're not going to do error bars. All right. Data labels. If you check that, it could, you know, it puts numbers on there. We don't want that. That gets in the way. All right. Trend line, on the other hand, we want that. Okay. Now you can choose what kind of trend it is. All right. If I look at this data, it looks very linear. All right. So in fact, one of the things with Hooke's law, the data should be very linear. And we're going to see from our data whether it does in fact match what Hooke's law tells us by putting lines through it. So we're going to do a linear fit, but there are other types of fits that you could do as you look at other forms of data. Okay, so whoops, we have a trend line. Now, whoops, let me check that trend line again. I think we want to see other things about the trend line. Okay, so I rechecked it. Oh, did I leave error bars on? I'm going to have to get rid of those because I was playing around with that. I don't want those error bars in there. This is linear. You can change the thickness of your line. You can change how dark it is. Label. We could put a custom label on it, but we can use the equation as the label, right? So right now we have that, and we can show R squared. Okay, so we have a linear. We put in a linear fit. All right, and we'll talk more in class about what that R squared value means. If it's 1, the data is exactly linear. Now, it might be rounded to 1 if it's just very, very close to being linear. But you can see how our data fits very nicely on a line in this. And so we get 0.999 as our R squared value. So that's what we have here. Okay. Now, going back, somehow, oh, I need to get those. I clicked error bars. Let's get rid of those. All right. So I have an equation. it looks like the force could be expressed as 17x plus 0.00491. Okay, so my best fit line almost goes through 0, 0. It looks like it has a slope of 17, which makes sense. This graph goes almost out to 0.5 and we went up by 8. So yeah, the slope should be around 17. So that tells us something we're going to see later. The slope is the spring constant. So that's good to know. So we want that equation. And we want to know how well the equation fits the data, which is the R squared value. Okay, so just make sure you use the equation and that you show the R squared value. Right? On to the legend. We aren't going to do anything with legends in this graph. All right. Horizontal axis. All right. It's already labeled. So we really don't have to do anything with the horizontal axis here. Okay, so let's just keep on going. That's the horizontal axis, vertical axis, same thing. We don't need to do anything. So we're up to grid lines and thickness. We really don't need to do anything. You could put in major tick marks. Right now, that's on. We're working with the horizontal axis. You could put in major tick marks, see how those tick marks showed up. But we don't really need to because we already had, whoops, we do want major grid lines. But we don't need to have those major tick marks show up. It's not really that helpful. So our graph really looks like it's ready to go. The main things are we have the title, the labels, the equation of the best fit line. We added a best fit line and we have its equation and the R squared value for that equation. So the chart looks ready to go. Now, I can just move that chart. I grab the chart and I can move it over so it's not on my data table because I'm going to want to be able to copy that to cut it into my report later. Okay, so anytime I click on it, it's ready to be copied and pasted. All right, so it's really an image of all of that will get copied and pasted. Okay, now before in the previous video, I said we should maybe do the return as a separate thing. Let me delete this second tab. So yes, okay. And what we're going to do is I'm going to show you, I have the chart already. If I duplicate everything that I just did, let's see, duplicate, it created another tab. And let's just pretend we were trying to do spring 2 for stretching. So I'm going to do that. Whoops, not spring 12, spring 2. So I clicked on the tab label and it's no longer a copy. So this will be spring 2 stretching. And now it looks exactly like what we had before. Okay, but I could actually, for spring 2, let's say that some of these numbers were, these numbers were bigger. This is 0.713. Okay, you can see that the data is instantly beginning to change. Okay, 0.942. Okay, the data points are already changing. 1.103. All right, so here's the height versus the force. Let's see, so as I do this, the stretch values. Oh, I'm sorry, the height should be going down. That's a problem, okay? So let's just say it drops. Let's say that this time, yeah, it's going to drop by about, we'll make it about 2 centimeters every time. So 0.62, okay, and 0.598, we'll say, okay, and the height is dropping to 0.5, we'll go 580, okay, and then we get, so I'm just making up pretend data here, 0.563, 0.541, 0.520, 0.503, and 0.4, whoops, 0.480. Okay, and we'll do that. Okay, and you can see how when I typed in the new data, I had, yeah, the chart is already there. Okay, so all the things I've done are, you know, we're already in there. I have very little work left to do. Just I can change up the data. Okay, now obviously when you're on the return trip, the masses go in the opposite direction. All right, so they would go from, in this case, it would be 800 back to 0, and the heights would actually go from a low number back up to a high number if this had been compressing. You know, everything else has now been calculated because we already had it all formatted on sheet 1. So it makes it quite easy to continue forward and figure out how much without having to reprocess this whole thing. Now, obviously, you might want to do something like if you double click on that chart title, okay, right away, the chart titles pops up. And obviously, this was still a stretching based on the data, but this might be spring 2 stretching. All right. And I think if that had been my data, I think everything else is good. Okay. Let me actually change one of these data points in the middle a bit. So let's say that was a 0.570. Look at, see how that data point shifted? And you can see the R-square value isn't as good now, okay, because that 1 point is a little bit further off of the line. So the linear fit isn't quite as impressive. It's still very good. 0.996 is a very high R-squared value. It's getting very, very close to 1, okay? So you can save a lot of time by doing all of the work for your first set of data, including making the graph. And then you have 5 more sets of data, but they can be created by duplicating, you know, the first set. So you can duplicate it 5 times and then rewrite, you know, put the new data in for that. Actually, what I would recommend is duplicate it and do the returning trip, and then you could duplicate each of those 2 more times because you have 2 more stretches and 2 more returns, and you can fairly efficiently get all of your charts ready by doing that. Okay, so I think that's just make sure when you do that you do update the tab name and that you update the chart title. Oh, and I probably write here, this still says spring 1. I probably want to change that to spring 2. And this was just fictitious data for spring 2 while it was being stretched. Okay. Oh, if you look at this data, you can see there's a much higher spring constant when we calculated that. Once again, this y-intercept value, it's near 0. It's not exactly 0, but it's close to 0, indicating, you know, that it did approximately go through 0, 0 when I did my linear fit. All right, I hope that works for you, and you can always come into office hours and show me your screen and what you're trying to do if you're having trouble with this.